NaCls. What's the smallest possible unit? NaCl. And what's that special name for that smallest possible unit? Formula unit. So what's the smallest possible unit of an ionic compound called? Formula unit. So from the same people that brought us Coulombic forces, a totally unnecessary vocabulary, non-concept, they're back with the smallest possible unit of an ionic compound is called a formula unit, or unit cell. But actually unit cell is easier. Formula unit is the one they usually use.
It's the smallest possible unit of a
ionic compound. Remember, ionic compounds are just made of NAs and CLs and NAs and CLs stacked up like oranges from the last chapter.
Yeah.
It'd be like having oranges and lemons, oranges and lemons, oranges and lemons. So what's the smallest possible unit of a orange-lemon combination? That would be an orange lemon. What's it called? Formula unit. What forces hold the formula unit together? Erstwhile positive and negative? Coulombic. Coulombic forces.
Can't say it right for the life of me.
Coulombic.
Okay, Coulombic. C-O-U-L, something or other, B-I-C.
What is the electron transfer between atoms is usually an endothermic process, and they give us this random formula that has moles and kilojoules, and I'm just really confused.
What does it say?
C. Is that?
Yeah, I don't know.
It's like Cl parentheses G parentheses plus E negative minus 349 K capital J / mole arrow.
Okay, so all they did,
It goes on.
all they did was elaborate on the electron affinity example I gave you about 5 minutes ago.
Oh, so that's all it is.
So remember the electron affinity? You add an electron to which side for electron affinity?
Electron affinity to the right side.
No, that's loss. Right side's loss,
Left
side's gain. So you put an electron on the left side. Isn't that what they have happening there?
There's a bunch of them.
Yeah.
But isn't the one you just mentioned about chlorine on the left side?
Yes, it is.
Okay, so what they're saying there is that, and then they're measuring Coulombic force as energy in joules. So they're saying if you want to add an electron to a chlorine atom, you have to add 345 joules of energy to get that chlorine to become a negative. Isn't that what happens in that example?
Yeah.
Yes.
Okay.
Well, we need to know that in our class, do you think?
You'll just need to know that adding an electron, electrons go on the left side, that it's called electron affinity when you add an electron, and that you put the energy on the left side also, because you're adding the energy to make it happen, aren't you? So all the energy, and also the energy is measured in what? In J's.
Joules?
Joules.
But I don't understand where they get the number
351?
or
351.
whatever number.
Yeah, from a table somewhere. They have to give it to you. There's no way you would know it.
Oh, okay, good.
It has to be given to you on a silver platter, called Domino's, they deliver. Because there's no way you can figure it out.
I think that's it, because I don't think we did oxyions or polyatomic ions.
Yeah, we did polyatomics.
We didn't do oxyions right.
Oxyions. What's
I
an
think that's it,
oxyion?
What
'cause
is lattice
we haven't
energy?
read these yet, so.
Lattice energy,
Well,
that's a good
We're
question.
going to cover that before.
Oh yeah, that's a
For
good
the next
idea, that's a
test?
good idea.
Yeah, good idea, okay. Lattice energy, what causes the NAs and the CLs to stick together? Coulombic forces. What if I talk about all the Coulombic forces in a stack of crystal lattice structures? What's it called? Lattice energy. So lattice energy is just all the Coulombic forces holding the structure together. That's probably way too simple an explanation. Way too clear and way too obvious. They probably make it like, somebody find the definition they give of lattice energy to see how obfuscating they can be.
Seriously.
The energy released when well separated atoms, ions, or molecules come together to form a crystal.
Okay, so actually there's one piece that I didn't mention that they have in that, and that is that so far we've been talking about energy added to the left side, right? In lattice energy, the energy is actually given off on the right side. So lattice energy is energy given off. You have to say that. That's the key point there that I didn't mention. Lattice energy is the energy given off when ionic bonds are formed. This is a tough question. See if you can handle this one. It may come up in the test, it may not. It probably will. But it's not an obvious question. However, you should think about this. This is important. When ionic compounds are formed, does the resulting compound have more energy or less energy than the individual pieces that compose the compound? Think about this conceptually. What's the advantage of two things coming together? Do they come together? They come together for a couple of reasons. Number one, they come together to get noble gas-like
Synergy.
structures, right? They achieve synergy by getting noble gas-like structures, right? By one giving, one gaining electrons. But what's also the advantage that we talked about previously of two things coming together? They come together for noble gas-like structures because noble gas-like structures make them more
Oh, stable.
stable. Okay, now, which is more stable? The high energy particle or the low energy particle?
Low.
Low. So what they want to do to become more stable is they want to give off energy so that they like reach a layer of lower potential energy. So that's why when they form these lattice structures, they end up losing energy. That's the concept part. They lose energy when they form lattice structures because they become more stable. And by becoming more stable, they become more stable by actually losing energy. So it's like calming down, you know. They get more stable when they're calm. When they're all emotional, they're not that stable. But as they get more stable, they calm down. And they have crystalline structures that are associated with that loss of energy. Okay, that's a concept thing. So, the question for the test would be, ionic compounds generally, A, have less energy than they started with. B, have more energy than they started with. C, have energy that remains the same, or D, none of the above.
Less.
Less. And instead of saying less energy, she could phrase it lower potential energy versus higher potential energy.
Ionic energy has lower.
Lower potential energy. Good. Okay. Keep going. What's next?
I guess that would be minerals and silicates.
I should probably talk about alloys.
Oh, not a mixture, but they're together. Oh, it is a mixture, but it's not.
Okay, didn't we talk about the Bronze Age versus the Copper Age?
Yeah.
Okay, so we know that there is no bond between copper and tin, right? It's like chocolate ripple ice cream. The tin is like rippled in between the copper, so it doesn't bond. It's not a Cu, an SN-Cu bond. They're just like laying next to each other, side by side. So it's not a bond. Because there is no positive bond, right? There is no red bond, remember what I said before? Because they both want to lose electrons, so why would they bond together? It's like copper says, I want to lose electrons. And tin says, no, I want to lose electrons. And copper says, no, I want to lose electrons. And tin says, no, I want to lose electrons. So how are they going to get together, right? It's like they can't. So therefore they don't form a bond.
After time, though, don't they somehow like begin to?
They don't. They just like slide closer and closer together, but they never really bond. All right. So what else is left there? Silicates. I don't know about that.
Any of the compounds containing silicon, oxygen, one or more metals, and possibly hydrogen. I guess pretty self-explanatory.
Silicon's in the oxygen column.
183.
No, it's not. It's in the carbon column.
Oh, skip a bunch.
Well, there wasn't really much in the other ones.
Oh, you're right.
So what does that little blue box have in it?
Oh,
Previous page.
it has
Yeah, okay.
running formulas compound containing a polyatomic.
Okay, we know how to do that, right?
Yeah.
Okay. What's left?
Hydrate and anhydrate.
A hydrate. Okay. So if you're dehydrated, what don't you have?
Water.
Good. So hydrate just means having
Water.
water. So they have a strange way of expressing it. What they do is they piggyback the water onto the molecule. So for example, if you have calcium chloride dot 3 H2O, this is called a hydrate. It's a water molecule hanging on to an ionic compound. Do they have some examples in the book?
No. Oh, the white salt is copper sulfate. Okay, it's something about salts when water evaporates turns into a crystal.
Well, here's a salt, and here's water.
So when the water evaporates, it's just the salt crystal.
Exactly. So when it happens, right now it's like salt water. And what happens when the water evaporates? It's just a salt. So this is called a hydrate because it has a lot of water. Everybody see the water? 3H2O. Could be 5, could be 7. How do I know the number? They didn't tell me. But a hydrate is just a salt with water. And usually they show it with a dot.
And then that turns into an anhydrous.
Anhydrous means dehydrated, which means no hydrogen.
So, okay.
So anhydrous means dehydrated. You can walk around saying, gee, I'm very anhydrated today.
And I guess that's the conclusion of the story.
What are those little blue
That's
fuzzies?
the review and assess.
Okay. So this is, as Cal mentioned earlier, an easy chapter, right? Next chapter is covalent bonds, and much more complicated. But this one's a piece of cake. Let's do the chapter review at the back of that chapter. The chapter test, actually.
Oh, yes.
Huh?
The test prep? Or?
The term review?
No, the next page. The last page there. Test prep. So what is that?
No.
This one?
I don't know.
Test, yes, test.
Yes. Multiple choice?
Yes.
Oh, it's your mom.
Val!
Oh, it's Val.
That's Val.
Yeah.
Oh.
Well, wait to come in the end, please. Okay, so the correct formula for a copper atom.
It's Val.
Way to show up, Beth.
Who won, Val?
Giants for sure.
How much?
4-3.
Yeah.
It's hella close.
Did Barry hit it?
No, they walked him 3 times.
Oh, man.
And then he...
They're afraid to play, please.
And did he score?
Yeah.
Good. Serves him right.
Where?
Yeah, what was that, Kyle? Oh, they're just gonna lose. It's okay. Sorry, continue.
Okay, so we're doing the test prep now. We finished the whole chapter, but it's all on tape. So you have to give me the tape when you're finished.
Oh, okay.
So I can keep it for posterity, and so that my image won't be lost and my soul will be intact.
Are you gonna
She was almost catching on to Cal because...
Are you kidding? Kelly let us. Like,
Well, she kept on like circling the things just for the flip flop and drop. She like
And
circled
Cal
it
goes
and
flip
like.
flop and drop, and she's like, yeah, that's taught by tutors. And then she looks at him and we're like, don't be associated with Cal.
And then Cal was like,
Shun.
or that's
Shun.
just common knowledge.
Yeah.
Wiggle, wiggle.
Yeah.
And then he yells out those common denominator. That kind of redeemed you.
Yeah.
Kind of redeemed you. And then
remember
Taylor and
that.
I just sit in the front and talk.
And Cal and I sit in the back. It's like,
This
Yeah.
is Miss LeBoy. I know.
But her
We were telling
Ionic
Miss
friends.
LeBoy about our Ionic friends. And she is positive and I'm negative, and we bond to form an Ionic bond.
Oh, that's good. Yeah, that'll work. So what's number 1 on the test prep?
The correct formula for a copper atom is that has lost 2 electrons is A CO plus, B CO2 plus, C Cu 2 minus, or D Cu 2 plus. So
Cal doesn't have a book?
No, it's right there. It's open.
it would
on the
be
couch.
the Cu plus 2.
Taylor, do you agree?
Yes.
And Val? No, you can keep that, Val. Or yeah, but somebody share. You can share with Justin.
Well, thank you,
Sir,
Chad. What
here
page
you
is
go.
it on?
191.
191. Alright.
Okay. One.
So what's number 2?
oh,
Taylor,
I'm
read it.
definitely gonna have to watch the tape before I know if I agree or not.
Yes, exactly. So just absorb. Val, your job right now is just to absorb.
Okay.
So Taylor, read the next one.
So the answer to 1 was what number?
D.
D. Okay.
Plus 2. Loses 2.
The electron neutrality principle, A, states that the number of cations equals the number of anions. Yeah.
anions. B is demonstrated in any polyatomic ion. C states that the net charge on a binary ionic compound is 0. D, all of the above.
I know A and C are correct, so it must be D. It must be. I just made that up.
I gotta see this one. I got one. What page are we on?
191.
I'll give you one, dude.
Oh my gosh. Turn the page and look at that sweet picture.
Okay, never mind, sorry.
That's crazy.
We can split it, we can split it.
Throw me that Reese's right now, woman. Fucking pig.
Okay.
Here you go, sir.
Ew.
I'm just three, so you can have two.
Sorry, Taylor.
Okay. Oh,
Very
that's hard.
unnecessary.
Ow.
People, I don't like number 2 at all. It's not all of the above.
But it's A and C.
I know. I know, that's why I didn't like it. What's wrong with B?
You stupid.
What, here, hint, polyatomic ion. What do ions have to have?
No.
By definition, an ion is either a,
Negative or positive.
exactly, and if it's negative or positive, it can't be neutral,
No, that's very odd.
right?
Point out to her, maybe she'll give us extra credit.
I doubt it.
No, she won't. She'll be like, oh, your tutor's very smart.
No, I pointed out another thing in the book, and then she gave me a point.
We'll discover it in class.
Okay.
I'm gonna come in that day, but I'll give myself some chapter tests and
Yeah, I was giving myself a chapter test all alone, and from column knowledge, I pulled this.
I believe the number 2 is incorrect. She'd be like, Jessica, you're so stupid.
But you're not loud. You're just there's something missing when you're not.
She's like, it was really quiet without you there. And I was like, oh. She's like, not that I'm saying you're loud, you're just always there. I was like, oh.
Always there. So number 2, what about number 2A? Is it true that all compound, I mean, the number of cations
Yes.
equals the number of anions?
Which makes it plus negative, which makes it A.
You know what? No, you know what? That's not true. You know why it's a trick question? Because what if you have a cation that's plus 2? Right? What if you have a cation that's plus 2?
Oh.
How many anions would you need to balance that one?
2.
Exactly. So you have 2 anions, but only 1 cation. Do you guys do I need to write this up, or can you see what I'm talking about?
No idea what you're talking about.
Me too.
So here, if I have Ca plus 2,
What does it mean?
guys, look. How many anions do I have?
2.
How many cations do I have?
1.
Are the number of anions equal to the number of cations?
Oh, okay.
The charges cancel, right? But the number of anions doesn't equal the number of cations. So that's a very tricky question.
That would be okay.
So the answer is really C, because all compounds are neutral. All right, next one. Neutral. Which of the following atoms can become isoelectronic? We talked about this earlier today. You weren't here, so that's okay. Just chill. Isoelectronic with a noble gas. So it can't be A, because A is already a noble gas.
Because they're the same electron configuration.
So it must be one that's close to a noble gas, which would either be the halogen or an alkali. They kind of straddle the noble gases. So do we have a halogen or an alkali here? I'll be darned. We sure do.
Argon?
Nope.
Potassium!
Argon is a noble gas.
Yeah.
So
Oh, never mind.
potassium is a
Alkali.
alkali. So it's a close to noble gas, almost there, right? Okay, and the next one. If you form a salt, we talked about this one just a moment ago. If you form a salt, energy is required to, we didn't talk about this, sorry. We talked about the opposite. We talked about forming lattice structures and releasing energy. This one says in forming, energy is required to do what?
Bond.
Yes, so what's another word? A, B, C, or D? Which one means bond?
to bring together the
D.
sodium, iron, and
Yep.
chlorine.
D. Good. But hang on. Let's look at the rest of them. First one, change chlorine to a gas? No. Add an electron.
D. Oh wait, sorry, I'm on 5. I thought we moved on.
Okay. Number 5?
D. D. D.
D. Good. Has to be molten.
I read about that.
What does molten mean?
Melted.
Melted. A molten pot of metal.
Molten rock.
Number 6.
Shut up, Val. Where am I?
Alkali metals.
Nope.
Because I don't know what the hell it is.
Alkalis are the first column metals.
Uh-huh.
What's the charge in the first column metals?
+1.
Say what? Say what?
Plus one.
Plus
Right.
+1.
For all of them?
Yes.
Every single one of them.
Is there like sometimes +1 and sometimes +2?
No.
No.
Always +1.
Always +1, damn it.
But are there some elements that are like sometimes +1 and sometimes
Yes,
+2?
transition.
The damn transition ones!
So which one of these would be a transition?
That would be the
C.
C.
Exactly. All of those transitions, they have multiple, 2 or more ions, right? Transients have 2 or more ions. Number 7. Factor that changes the unit cell structure for NaCl from that of the factor that changes the unit
That
cell
is
structure.
energy?
Can I have a piece of paper?
Seems like it.
That's stupid.
I don't know what the answer is for 7.
Lattice energy.
How dare you?
Factor that changes
The
the unit
English
cell.
only sounds right with lattice energy.
Right answers.
Oh yeah, Val. Thanks for telling me Sarah liked Taylor.
G. Wait, you
She
guys aren't
doesn't.
going out anymore? What?
Yeah, we broke up 2 days ago, and she's already gonna go out with Taylor.
TH?
According to
Huh?
yeah, Taylor Humphrey.
I thought he and Regina were an item. Did they split up?
I don't know.
They were never really together. She attacked him and decided they were going out, and he was like, "You can't be mad about this. Like, we were never really going out." And she's like, just like that.
DCB.
Okay. I don't know what to say about number 7.
That was really weird.
The factor that changes unit cell structure.
I can't believe that he knew. D.
Wait, DCB.
D.
Hey guys, I actually don't know the answer for number 7.
Can you believe that?
Yeah. Wow.
What the hell? Like, that doesn't make
C.
any sense.
And 7 we just...
Wait, how do you get Na to Cl?
Well, one of us will ask and everyone
Yes.
has to listen.
Well, she probably won't know either, though. I mean, this is just a weird question, I guess. I don't know what they're getting at here. I know
I'm guessing A.
cesium is
Told me
bigger,
not to tell it stuff like
Yeah.
that.
but so does that mean size? I really don't know. So I'll skip number 7. If I don't know, it must be a lousy question, right?
Yeah,
Of
There we
course.
go. Good. Okay.
Like Miss Manning.